Welcome back, students. The last topic that we'll talk about today is the bringing together of two topics that we studied earlier in the semester. The first one is a FOIL problem, but it's a special kind of FOIL problem. A FOIL problem where the numbers and terms match, except one is positive and one is negative. Do you remember what happens when we use FOIL on this type of a problem? Let's try it. We'll multiply the firsts, 4x squared. Multiply the outers, negative 10x. Multiply the inners, positive 10x. Multiply the lasts, negative 25. As usual, the outers and the inners are like terms, but this is a special case where the outers and the inners add up to 0. If we let those add up to 0, then we're left with 4x squared minus 25. This creates kind of a nice shortcut. If we notice that these numbers are the same as these numbers, but one positive, one negative, we can just count on the outers and the inners canceling out and giving us 0. Let's try it again. We'll multiply the firsts, but the outers, 9x, and the inners, negative 9x, are going to add up to 0. Let's skip those and multiply the lasts. Feel free to use that shortcut anytime you notice that the two binomials have a positive and a negative, along with the rest of the numbers all being the same. The second topic to review is how to rationalize a denominator. It's considered bad form to have a square root in the bottom of a fraction. Here's how we fixed it in the past. We multiplied the fraction, top and bottom, by the same value. That way it doesn't change the value of the fraction. What do we multiply top and bottom by? Well, we'll multiply top and bottom by the square root of the bottom. Why does that work? Well, in the top, we get the square root of 6. But that's okay. We don't mind square roots in the top. In the bottom, we get the square root of 4. But I can simplify that because the square root of 4 is just 2. This fraction has exactly the same value as the original fraction, but it does not have a square root in the bottom. We've rationalized the denominator. Let's try it again. You're allowed to take this fraction and break it apart into a radical top and a radical bottom. Of course, the square root of 1 is just 1. Let's copy this problem down here where I have more room to complete it. Now, I'm not supposed to have a square root in the bottom of a fraction. How do we get rid of that? We multiply top and bottom by the same number. What do we multiply by? We multiply by exactly what is in the bottom. In the top, I have 1 times the square root of 2. I don't care about square roots in the top. In the bottom, the square root of 2 times the square root of 2 is the square root of 4. But the square root of 4 is just 2. This fraction has the same value as the fraction we started off with, but it does not have a square root in the bottom because we rationalized the denominator. All right, go try a few of these, and then we'll wrap things up with one last type of problem.